use the intermediate value theorem to show that each polynomial has a real zero between the given integers. Okay, so you might want to write let's write intermediate value theorem. We can just abbreviate it here. Intermediate value theorem. So that's what your directions are going to ask you to use, the intermediate value theorem. And this is just a process that's asking you to prove that your graph, and we're not having a graph here, but I want to give you a visual. So if this is 1 on the x-axis, they're wanting you to prove that your graph is going to cross the x-axis somewhere between 0 and 1. That's the question. So it says use the intermediate value theorem to show that your graph has a real, meaning not imaginary, a real zero, a real place where the graph's going to cross the x-axis between 0 and 1. Not exactly at 0.5, it could be 0.1, it could be 0.2, it could be 0.9, but just anywhere between 0 and 1. And the reason that this is important is if you go back to what you did last night for homework and you listed the zeros, weren't those all whole numbers? When we found all those x-intercepts, they were like -2, +2, +5, -3, and we could not find any decimal values. So sometimes our graph doesn't cross at a whole number, doesn't cross at an integer. And we kind of need to know, does it really cross there, because we were not going to be able to tell by our factors. Okay, so what you're going to do here is you're going to make a little t-chart. And once I do this, you're going to go, that's all we're doing. But you need to really understand what we're doing. It's not like it's a lot of algebra here. And if they say between 0 and 1, those are x values. So you're going to put 0 and 1 in your little t-chart. Then you're going to get out your handy-dandy calculator. And if you're plugging in 0, please tell me you can do that in your head. When x is 0, what will f of x be? Don't use your calculator for 0. It's going to be 2. Because both of the x terms, if you put in 0, will go away and you'll just have that 2. If you want to do the 1, you can, but I believe a lot of you could substitute 1 in your head and figure out what f of x would be. One cubed is 1, minus 4 times 1 squared would be minus 4. 1 minus 4 would be -3, and -3 plus 2 would be -1. Okay, so however you want to do this, if the numbers are reasonable like these two, you can plug them in without using a calculator. If you need to use your calculator, you can. So what we're looking at is we're looking at just 2 points on our graph. Just 2 points on our graph. We're not graphing here, but I need to show you what this would look like. So everybody agree that 0, 2 would be here. And 1, -1 would be here. And I'm going to show you just the graph on this one so you can get an idea of what's going on. So your roller coaster graph, this would just be a section of your roller coaster graph. And your roller coaster graph would cross through those 2 points with consecutive x's. And these 2 x's that they give you will always be consecutive. They'll be 0 and 1, or 5 and 6, or 7 and 8. So reason in your mind why without doing the graph. Okay, so here's a visual of those 2 points. But if I didn't have the graph, how would I know that the graph crosses the x-axis between those 2 points? If I just knew the points 0, 2, and 1, -1. How would I know the graph would cross over the x-axis? Just by looking at the ordered pairs.
From +2 on y to -1 on y.
Okay.
Across the x-axis.
So 0, 2 is above the x-axis, and 0, -1 is below the x-axis. So anytime you have a point above the x-axis and then the next consecutive point is below the x-axis, then that'll be a place where your graph is going to cross the x-axis. Same thing goes for if that first point were below the x-axis, meaning the y was negative, and then we jumped up to a point above the x-axis where the y was positive, then that would prove that we had a real zero between those two x values. So you're not graphing at all here, okay? But hopefully the graph makes a little sense. All you're looking for here is that these two y's have opposite signs. If they have opposite signs, not opposite numbers, but just opposite signs, one is positive and one is negative, or one is negative and one is positive, then that proves one point's above the x-axis, the other one is below, and when you connect those 2 points, your graph will cross the x-axis between those two numbers. So all you're doing here is plugging in the two x's that they give you, and then you're checking to see if your y's have opposite signs. That's all you're doing. Alright, let's do one more under this set of directions. Same set of directions, number 40. A little bit more complicated equation. So it says f of x is equal to 3x cubed minus 8x squared plus x plus 2. So that's the equation of our graph. We want to prove by using the intermediate value theorem that we have a real zero between 2 and 3. We have a real zero between 2 and 3. So we're going to make a little t-chart. We're probably going to use our calculator on this one. We're going to plug in 2 and get the f of x, or the y value for 2 when x is 2, and then we're going to plug in 3. I'll give you a couple seconds to plug that in. And again, all we're looking for is that one y comes out to be positive and the other one comes out to be negative. Or the first one's negative and the second one's positive. We're just looking for opposite signs. What are y'all getting for 2?
-4.
-4. And 3? 14. Anybody get anything different? So is the point 2 -4 above or below the x-axis? 2 -4 would be below, and 314 would be above. And when you connect those 2 points, the graph would cross the x-axis somewhere between 2 and 3. Doesn't tell you exactly where, but it would be important for us to know that our graph actually crosses there. This is going to be the only way that we can find out where the graph crosses at decimals and fractions. Okay? So your only work is just this little t-chart. Okay? These are all going to cross between 2 and 3. They just want you to practice this little skill of where you plug in the numbers and you realize you got to get opposite signs on your y's to show that. Okay? Alright. Next set of directions are the big directions. This is where we've been studying all these little skills. It's all going to come into play. And I'm going to write the directions down just so we have them. I'm going to try to stick them in the upper left-hand corner. It's going to ask you to use the leading coefficient test to decide what your ends of your graph are going to do. That's the A part. The B part is going to ask you to find intercepts. Actually, it's going to ask you to find the x-intercept and state whether the graph crosses or touches and turns. So we're going to find any x-intercepts, and we're also going to talk about cross or touch and turn. C is going to ask us to find y-intercepts. D is going to ask us to determine if there is either y-axis symmetry, origin symmetry, or neither? E is going to ask us to find any additional points that are necessary to make our graph complete. So you might be wondering, why don't we just make a T-chart like that worksheet that I gave you yesterday? The reason we can't just make a T-chart is we don't know all the graphs go between -5 and +5, or -10 and +10. So we would have to be guessing about the x's to choose. So we don't know. These graphs are very unusual graphs. They're very unpredictable. There's some things that we can predict, but we can't predict everything. All right, so let's start with number 42. These are the big, tough problems in this section. So 42 gives us this polynomial. F of x is equal to x cubed plus x squared minus 4x minus 4. And then we're going to go down our directions, A, B, C, D, and E. X cubed plus x squared minus 4x minus 4. A says let's use our leading coefficient test. So that means we need to determine, first of all, is the degree of this polynomial even or odd? It's odd. That's the highest exponent is 3. That's odd. So that means the ends of the graph are going to go in opposite directions. Then you have to look at the leading coefficient. What's the leading coefficient in this equation? +1. So if the degree is odd, the ends go in opposite directions, the leading coefficient is positive, that means the right-hand side is going to go up and the left-hand side is going to go down. And I just do arrows right there. You can write the left falls and the right rises. You can just draw your arrows. It doesn't matter, but we need to know when we get finished with this graph, the right-hand side must go up and the left-hand side must go down. Okay? Now the second thing they're asking us to find, bless you, are the x-intercepts. The x-intercepts come from factoring our polynomial. So is our polynomial already factored? No, it's not. Do you see any way that we can factor it? Okay, somebody said grouping. So we're going to, really when we're solving, that f of x technically goes to 0. And we start to factor. So we're saying grouping because we have 4 terms. What's the GCF of the first 2 terms? X squared. When we take out an x squared, we get x plus 1. And that means we want our other group to be exactly the same. So we want our other group to be x plus 1. What are we going to factor out of the last 2 terms to get x plus 1? -4. Then we can factor out our group. So if we factor out of x plus 1, what are we left with? X squared minus 4. And then we're almost finished factoring. The x squared minus 4 is called the difference of squares. So it factors into what 2 binomials? X plus 2 and x minus 2. Any questions about my factoring there? We're still on the B part. X-intercepts come from factors. So if your polynomial will factor, you'll have to factor it. All right. So our x-intercepts are going to be, we have 3 of them. What are they? -1. Is that going to be a place where an x-intercept where the graph crosses or touches and turns? Cross. Now we don't have to write down the multiplicity. We don't have to write down 1. But we have to think it. We have to look at that factor. It occurs once. That's odd multiplicity. So the graph crosses at x equals -1. The next x-intercept is -2. The multiplicity of that factor is 1. So that's where the graph just crosses. The next x-intercept and the last one is +2. The multiplicity of that factor is 1, which is odd. So that's another x-intercept where the graph just crosses the x-axis. All right, that's all B is asking you for. That'll be the hardest part probably. C is asking you for y-intercepts. So you should be able to do this without any work to find the y-intercepts. Let all the x values go to 0. That's just going to get rid of all of the first 3 terms. And your y-intercept is -4. Come on in. We didn't mark you absent. Somebody knew where you were at. Alright, that's another important point that we can have on our graph. D says, is there any symmetry? We studied this, I don't know, about a month ago. If you, would this graph have y-axis symmetry? To have y-axis symmetry, all the exponents have to be even. Are all the exponents even? No. If it has origin symmetry, when we put a negative x into all the x's, we would have to get a function that's exactly the opposite. Okay, that's not going to happen because that constant term -4 is never going to change to a +4. So I can kind of look at just that last term. So it's not going to have origin symmetry. So we don't have any symmetry here. That means that's not going to help us out at all. If we have some symmetry, we know sometimes what both sides are going to look like without having to have extra points. All right, E says find some additional points. So we won't know the E part until we sketch out what we know prior to the E. Okay? Any questions before I get to the graph? All right, I know this is pretty hard. So what you're going to do, don't go to graph paper, just sketch out a nice y and x axis on your notebook paper. So we're going to keep in mind that the left-hand side's got to go down and the right-hand side has got to go up. And let's start by graphing the x-intercepts. So as I'm looking at those, they're -1, -2, and +2. So I'm going to go like maybe 4 to the left and 4 to the right. My y-intercept is -4, so I'll go about up 5 and down 5. I may have to add some more, but I'll just kind of get that started. So I know what I've got to graph. If I have to add some more dashes, I will. All right, so before we do left, down, up, right, let's graph in the intercepts. So we know we have an x-intercept at -2, -1, and +2. It's a little bit bigger. -2, -1, +2. We have a y-intercept at -4. We know the left-hand side goes down, and we know the right-hand side goes up. So what I'm about to do now is I'm about to sketch in a sketch, just kind of an idea. So if I start on the left-hand side of the graph, okay, I know the left-hand side's got to go down. And then the first x-intercept I'm going to come to is the -2. And then if it crosses again at -1, then that means the graph has to go up. I don't know how high, but it has to go up, and then it has to turn back around. And it has to cross at -1. And then it has to come down, and it has to cross the y-axis at -4. I don't know that -4 is the lowest point, so I'm going to keep going. I don't know how low it's going to go right here, but then I know it's got to take a turn, and it's got to come back up and cross at the last x-intercept a +2, and then the right-hand side has to go up. Okay? So I got all of that information just by knowing the end behavior, left, down, right, up, by knowing where it crosses the x-axis, and by knowing the y-intercept. So when it says additional points, I do need some additional points. So I have a question mark here. I don't know how high that goes. All right? And I also have a question mark down here. I don't know how low that goes. So you're going to pick 2 more x's, and you're going to figure out how high the left little hill goes and how low the little valley goes. So this is the hardest part for some people. So how would I decide what x to plug in if I need to know how high this is? Well, I come down here, and what would this x be here if I want to know how high that point is? we'll just go right in between those two x's, and that would be negative 1.5. And then if I want to know how low this point is, just go up. Okay? We know something about when x is 0, and we know something about when x is 2. We want to know what the graph is doing when x is 1. So we're going to plug in negative 1.5 for x. So on your E part, I'm going to go up here because I'm out of room. We're going to make a little T-chart, and we're going to pick a few more x's. We're going to pick negative 1.5, and we're going to pick 1. And you're going to have to look at your graph, and you have to decide what extra points you're going to pick. And it's just based on what's kind of unknown. So definitely use your calculator here. You might can do the 1. I definitely wouldn't try the negative 1.5 without a calculator. All right, let's look at 46 has a touch and turn. Let's do 46 as our last example. So here's our equation. The A part is asking us to use our leading coefficient test. So who can tell me what you think the ends, we don't have to think, we can know this because this is a rule. What are the ends of this graph going to do? Okay, somebody said they're both going to go down. Can anybody explain that?
Because the leading coefficient is negative and your exponent is even.
The leading coefficient is negative, the exponent is even. The highest exponent is even means the ends are going to go in the same direction. The leading coefficient is negative, they go down. Alright, B says find your x-intercepts and decide whether they cross or they touch and turn. So that means we have to factor. So we want f of x to go to 0. What do y'all think about factoring this? It's not a very long polynomial. Got any ideas? Okay, x squared. We might even want to factor out a negative x squared. Anytime the first term is negative and all you can do at first is factor out a GCF, sometimes it's helpful to go ahead and factor out a negative. It makes the rest of the factoring easier. What do you get when you factor out a negative x squared? You get x squared minus 4. Is that completely factored? No. X squared minus 4 is called the difference of squares, and it factors into what? X plus 2 and x minus 2. Alright, so let's talk about that little negative. That negative is really a negative 1. And does the negative 1 have anything to do with our x-intercepts? Just the negative 1 all by itself? No, it's just a number that doesn't have an x in it. So that doesn't have anything to do with the x-intercepts. So look at the first factor that has an x in it. That's x squared. If you set x equal to 0, you just get 0. Okay? What's the multiplicity of that factor? 2. So since the multiplicity is even, then that's an x-intercept where the graph is going to touch and turn. Go to the next factor, set it equal to 0, and you get negative 2. The multiplicity of that factor is 1, so that's just going to be an x-intercept where your graph is going to cross. Last factor, x minus 2, set equal to 0 is 2. That multiplicity is odd. That's just going to be an x-intercept where your graph crosses the x-axis. Any y-intercepts? If I let x go to 0, what will y be? 0. Is there any symmetry? if all the exponents are even, it has y-axis symmetry. So yes, it has y-axis symmetry. You might want to write down all exponents are even.
Well, do you have to look at the original problem to determine that?
The original, I am looking at the original problem. Yes, you would have to look at the original problem. If all the exponents are even and you put in a negative x for all the x's because the exponent's even, the problem won't change. Okay? Odd is a little bit harder to determine than the even functions. Even functions have y-axis symmetry. Odd functions have origin symmetry. All right, and the E part, we won't be able to do that until we actually get our graph sketched. Okay? So, if you understand what we're doing, this one's probably going to be a little bit easier to graph because there's y-axis symmetry, so we know the left-hand side is going to be the same as the right-hand side. So that's going to be helpful if we know that there is symmetry. So I'm going to check out what values I have. I have x-intercepts from -2 to +2, so I'm going to just go out 3 on the x-axis, and I'm going to go ahead and go up 3 on the y. Alright, so I want to keep in mind that both ends have to go down, but I'm going to go ahead and put my intercepts in first. So we have x-intercepts at -2, 0, and +2. At -2 and +2, the graph is just going to cross, but at 0, the graph is going to touch and turn. Okay, so this is where I've got my y-intercept also graphed. If the x-intercept is 0, you'll have a y-intercept of 0. Alright, so this is where you're just going to kind of sketch in. We know the left-hand side goes down. We know the right-hand side goes down. And we're going to, on the left-hand side, we're going to come up. We're going to cross at -2. Then we know the graph goes up. We don't know how far it goes up, but we know that it goes up. And then we know that it's going to have to turn around because it has another x-intercept. So then it turns around, and at 0, it touches and turn. So it doesn't cross at 0 this time. It just touches the x-axis and it bounces back up. And then we know because it has y-axis symmetry, then it's going to go up the same amount on the right-hand side as it did on the left-hand side, and it will have to turn back around to cross at that last x-intercept. What we don't know is we don't know how far up both sides go. We know they go up the same amount because the graph is the same on the left as it is on the right because it has y-axis symmetry. So this time you only have to pick one value. And I could pick one or the other of these numbers. What could I pick? I could pick 1 or I could pick -1. It won't matter. I could pick 1 or -1. I should get the same values here. So on the E part, I am going to pick, you can pick 1 or -1, it won't matter. You should get the same exact value. Y'all going to tell me what you would get? If you're using your calculator, you're going to do negative parentheses 1 to the 4th plus 4 times 1 squared, or you might even be able to do that one in your head. It's amazing how we mess up on our calculator when we could do something in our head. So what are y'all getting there? Y'all scared to say it? 3. So you could have done -1 or +1. It doesn't matter. Both of those should be 3. So again, I had no idea. I just kind of drew it in there to get a sketch. So I got to go back up here. And now I know that each of those sides go all the way up to 3. And then that would complete my graph.